Hello everyone, my name is Abdullah Mubarak. In this occasion, I will present to you one of the project that I had been contributed to. This project is the main part of my work as software engineer at Justisio, a startup that provides a service for the legal domain. I will mainly talk about my contribution to this project, that is, improving the retrieval augmented generation AI chat system. Before I dive in, it's important to understand the basic structure of Indonesian legal regulation. As you can see in the diagram, there are regulation, or in the Indonesian term is aturan or peraturan or undang-undang, which is the top abstraction level. Within each regulation, the content is divided into articles, which are called pasal. Finally, each article is broken down further into verses or ayat. To give some context, the primary purpose of the Justisio system is to answer users' questions with the relevant legal phrases and their metadata, like the first number, article number, or regulation number. However, when I began my work, the system had several critical problems. First, it was relatively slow, taking around 1 to 2 minutes to provide an answer. Second, the answers were sometimes inaccurate. My initial testing showed it provided incorrect phrases for 5 out of 30 queries. And in some cases, it couldn't find the related phrase at all, although the phrase it's supposed to retrieve is actually exists in the database. It's account around 6 out of 30 test queries. Additionally, the survey from several lawyers and also entrepreneurs shows that they deem the answer structure is too short and also lacking details. They also want additional feature that is to show the actual regulation file when a phrase in the answer is clicked. This brings to my task on this project, which was to enhance the ITB-based chat system across several key areas. Specifically, my tasks were to first, to improve the accuracy of response and to also reduce the latency. Second, to research and implement methods to improve the answer structure so that the AI's response were logical, consistent, and more detailed. And finally, I also tasked with adding a new feature that is the ability uh, to show the source regulation document directly within the interface when a user clicks on a site at first. Before I explain further, I want to quickly cover the retrieval augmented generation methods or RAG. As you can see in the diagram, when a user asks a question, first in the retrieve step, the LLM models will receive the user's query, and then it searches the database to find the specific data that are relevant to the user's question. Next, in the augment step, it takes the relevant information it found on augments the relevant information, we call it context. Uh, it augments with the original questions, and then it's wrapped in a prompt that essentially says something like, "Here's the user question, and here's this specific information that you will generate answer of the user questions. Only use this specific information." Finally, in the general step, the AI model will that receive this enhanced prompt will generate an answer. Because the answer is based on or grounded in specific data, which in this case a valid legal regulation document, it will be far more accurate, reliable, and trustworthy. This is especially important in legal domain. Next, I will explain the existing database. So it's stored regulation content per page and also has separate tables for the content of verses and articles. It also contains information uh, linking a primary regulation with its child regulation or aturan turunan in Indonesian term. It also store in the store vector store for a semantic searching of the embedding vector of the verse and articles. The chat logic was built using a line graph while using TypeScript as the language. The process flows through four main nodes. It starts with query or response, and then go to the tools node, and then to the generate node, and finally to final response processor. I will explain further in the next slide. Diving deeper into that flow. So first, the query or response node was the entry point. It will set the AI's persona as Jivara, an Indonesian law expert, and also connect with the next tools to determine which tools to call. The tools node was the context retriever. It handled the execution of tools calls from the query or response. And there are two tools that exist at that time, that is retrieved by articles and retrieved by verse. So it starts in the content, embedding vector content of the articles or by the verse. Then it goes to the generate nodes, which is the main answer, which where the main answer was constructed. It used a more detailed prompt and taking the user's query and the content retrieved by the tools to create a comprehensive response. And finally, the final response processor handled a cleanup task like updating the user's token usage and also saving the conversation to the database. And the core challenge I faced were threefold. First, the massive scale of the data, over 300,000 regulations with 10 plus each articles, and each article have dozens of verses each. And second, this scale mean that traditional RNG approach was causing high latency and poor quality answer for some prompts. Sorry, for some query. And third, the final answer also lacked a detailed structure and more consistent structure. To solve these issues, I designed and implement several solutions. First, I introduced a new tools that is hypothetical embeddings to better capture the user's intent. Second, I developed a hierarchical retrieval strategy as tools that will searching based on the summary and keywords to improve speed and accuracy. And third, I also re-engineered the generate prompt to enforce a more consistent and also more details for every answer. I will explain more in the next slide. Let's look at the implementation, starting with hypothetical embeddings. These tools takes the user's query and using a specific prompt that instructs the LLM to act as a legal expert. Then it generates a hypothetical explanation for that query. The vector embedding of this hypothetical explanation then used to search the vector store for the actual legal verses. The goal is to bridge the gap between a user's potential vague or ambiguous questions and the precise language of the law. This is the prompt template used on the screen is the main part of this solution. First, I set the AI's role as an expert in Indonesian law and give it a clear task that is to generate a hypothetical legal explanation. The most important rule is the one under instruction. I explicitly forbid the AI from citing specific articles or ayat. This is critical because the goal isn't to create the final answer, but it's to generate a theoretical paragraph that captures the ideal meaning or the intent of response. I also enforce a formal language and a clear logical structure to ensure the quality of the response. Next, the retrieve hierarchical approach needs some several steps first. So for the first step, I create and run a job program to extract a summary and keywords for every single regulation in the database and sort this as vector embeddings. So when a user asks a question, the search now happen in two stages. First, it will search against the summaries and keywords to quickly find the most relevant regulation, and also to ensure it didn't miss anything, I used a hybrid approach combining both factual similarity search and also full text search. Then it searched only within the articles of those top ranked regulation to find the specific content. Finally, the results are ranked to select the top 10 most relevant articles to pass to the generation or the next step. To address answer inconsistency and fulfill the user request, I modified the generation prompt. First, I implement the feature for showing the regulation document. I added a strict guideline that all regulation citations must be formatted as markdown links, and using the regulation title as a text and a unique ID to form the URL, which will be processed by a function that I created at the front end to show up the regulation document pop-up. Second, I also enforce a consistent answer structure. I instruct the AI to always open with a seminal with the essential answer first or the direct answer first, and then develop its point through logical themes, and then provide specific details like penalty amounts and time frames, and include exhaustive examples. Finally, I added a summary or source section at the end of the response, listing all primary legal documents with their clickable links. Now for the results, which were quite interesting. I test several combination of the new tools. First, using hypothetical embeddings alone barely change anything. It's just improving the accuracy on only one or two queries. However, using the retrieve hierarchical method by itself had a huge impact. It dramatically increased accuracy, reducing the rate of miss first to less than 10%, and it cut the response time to under 60 seconds. I also tried combine everything, like hierarchical plus the odd retrieve by first and also retrieve by article. This gives the best accuracy with a miss rate below 5%, but it was too slow, pushing the response time over 2 minutes. The sweet spot was combining the retrieve hierarchical with retrieve by first. This combination kept the high accuracy with a miss rate below 5% and a much more acceptable response time of under 90 seconds. This is the most balanced and effective configuration I have ever tried. And also just to complete the picture, I also test combining retrieve hierarchical with hypothetical embedding. This combination is also greatly improved the accuracy, getting the miss rates below 10%, but didn't affect much of the response time. The qualitative results from my prompt engineering were also clear. As you can see from this example answer, the response is no longer just a block of text. It has a clear structure, starting with an overview, followed by the dasar hukum utama or legal foundation, and then a breakdown of punishment types. And this is a direct result of the new prompt I created. And here, you can see the successful implementation of the feature requested by users. So when a regulation link in the chat response is clicked, the system now displays the actual PDF of the legal document directly in the interface. But while the results are good enough, there is still room for improvement. There are three main challenges that remains for the chat system. List of us. I want to decrease the chat latency even further. So maybe with implementing more aggressive and strategic indexing in the database to speed up the lookup process. Second, I also noticed that some child regulation or aturan turunan are still not paying retrieved reliably. And to fix this, I need to perform an audit to ensure all these relationships are correctly mapped in the database. Finally, the client deems the answer can be more detailed using more detailed prompt. Uh, this is needs discussion with legal expert and lawyers. That's all for me. Thank you for your attention.